This question is about iron testing. Describe how a student could distinguish between aqueous solutions of potassium nitrate and potassium sulfate. So the potassium's the same, so it must be about nitrate ion versus a sulfate ion. And this is coming from the A1 required practical. Now, nitrate ions don't really do anything with any other reagent, but sulfate ions, there's definitely a way to identify sulfate ions, in that sulfate ions are going to give a white precipitate when reacted with barium ions. Now, barium, you can't just write barium, it's not barium, it needs to be Ba2+, but that's not a reagent, so we need to think of something that contains barium 2+. So typical reagent would be barium chloride. You could have barium nitrate, barium hydroxide, and you would see a white precipitate with the sulfate containing compound. And with the nitrate, you would see a colourless solution or no visible change. Now, second part of the question, it says, how could a student distinguish between magnesium chloride and aluminium chloride? So this must be about the positive ions. Now, this is coming from the A2, a mixture of the A1 and the A2 required practicals. They both react with sodium hydroxide. That's going to be our reagent. With magnesium hydroxide, we're going to get sparingly soluble white precipitate of magnesium hydroxide. So with our magnesium ions, we're going to get that sparingly soluble white precipitate. But slightly different if we use aluminium chloride, because we will get a white precipitate of aluminium hydroxide. So just get that, a white precipitate. But that white precipitate, aluminium hydroxide, is amphoteric. So if we keep adding that alkali, that sodium hydroxide, then it's going to redissolve to give a colourless solution. So we'll see a white precipitate, but then it will redissolve. And that's kind of a little bit of a trick question, because it's trying to see whether you just write white precipitate for something and colour solution for the other. They both give a white precipitate, but the aluminium hydroxide, being amphoteric, will then redissolve in excess, because it's going to form that formula where you have AlOH4 and a minus. Yeah, the aluminate ion.